In this lecture, I will describe the compressible fluid flow through nozzle and diffuser. First of all, what is fluid? What is fluid? A fluid is defined as a substance which continuously deforms under the action of shear forces. And we can consider the liquid and gas are fluid. The fluid, two types of fluid basically we consider here. First of all, incompressible and compressible. What is incompressible fluid? A fluid is said to be incompressible if its density or a specific volume does not change or change very little with its change in pressure or temperature or volume. We can consider liquid are incompressible. Okay. And compressible, a fluid is said to be compressible if its density changes with a change in pressure or temperature or velocity. We can consider gas is a compressible fluid. Now, what is nozzle? What is nozzle? Nozzle is any duct which increase the kinetic energy, which will increase the kinetic energy by expense of its pressure. And what is diffuser? What is diffuser? Diffuser is a passage through which a fluid loses kinetic energy and gain pressure. So, kinetic energy will decrease and pressure energy will increase. That means, diffuser is a passage through which a fluid will loses kinetic energy and gain pressure. The same duct or passage may be either nozzle or diffuser, depends on the end condition across it. Now, types of nozzle. Types of nozzle. Types of nozzle. Two types of nozzle, convergent and divergent. Sorry, convergent, divergent. Divergent. Convergent nozzle, convergent, divergent nozzle. And convergent nozzle, in convergent nozzle, the cross section area gradually decreases towards the exit and minimum at the outlet. If I will draw the convergent nozzle, that will be like that. If this is inlet, this is exit. So, its cross section area gradually decrease towards the exit and that will minimum at the outlet. And convergent, divergent, the diameter of the nozzle at first decrease and it becomes minimum at throat, and after that it will gradually increase up to the exit. If I will draw the convergent, divergent nozzle, first of all gradually decrease, then that will increase. So, this is the convergent, divergent nozzle. So, if this is inlet, this is exit. So, first of all increase, first of all area is going to decrease, then increase, area is going to decrease and increase. So, this is the convergent and divergent nozzle. Now, what will be the nature of pressure and as well as velocity profile? If I will draw the pressure and velocity profile, suppose this is pressure and this is velocity. So, pressure and velocity profile. So, in pressure line, suppose pressure line will be, first of all initial pressure was high, then that going to decreasing here. So, this is the initial pressure and that will going to decreasing. So, this is pressure line. And what will be the velocity profile? The velocity initial was here, the velocity is going to increasing here, just like that. So, this is velocity profile, velocity, is that clear? And in this direction length or area, clear. Now, next we will discuss the effect of friction. We will discuss the effect of friction, in nozzle. To understand the effect of friction in nozzle, we have to draw the HS diagram. So, as we know that HS diagram is just like that. If you draw two pressure line, this is the high pressure line and this is low pressure line. So, if this is pressure P1 and this is pressure P2, suppose this is the initial point of the steam. If friction is negligible, that means adiabatic heat drop, that is the drop of the enthalpy during the adiabatic expansion, that will follow the path. Suppose this is 1 to 2 adiabatic, suppose 1 to 2s. If friction is taken into consideration, the heat will produce during the flow of steam due to the friction is added to the steam. In that case, flow through the nozzle will be, that means in that case due to the friction the heat will produce and that will added to the steam, and that is why enthalpy drop will decrease if you compare with the adiabatic case, and this line will follow 1 to 2, and due to the low enthalpy drop the kinetic energy will or velocity will decrease. So, from this diagram it is obvious that enthalpy drop at adiabatic case, that means 1 to 2s, that means H1 minus H2s is greater than that of H1 minus H2, and due to the friction the enthalpy drop going to decrease. And if we consider the enthalpy drop due to the friction, that means whenever we will consider the friction in the nozzle, then there will be another term, that is nozzle efficiency or coefficient of nozzle. So, nozzle efficiency or coefficient of nozzle, that will be nothing but the ratio of that has been defined by K, ratio of del H actual divided by del H adiabatic. Is that clear? Del H adiabatic. That means actual heat drop divided by adiabatic heat drop. So, actual heat drop or actual enthalpy drop is equal to what? Coefficient of nozzle into adiabatic heat drop. Heat drop. Okay. So, we can write H actual is what? This one, H1 minus H2 is equal to K into H1 minus H2S. With consider this effect, next topic we will discuss the velocity of the steam at the exit nozzle. Whenever we have to consider the velocity of the steam, suppose this is a nozzle. This is a nozzle. This is a nozzle. There will be a control volume, and suppose this is inlet, and suppose this is bottom line, and this is Z1, this is Z2. That means we consider this is horizontal nozzle Z2, just like that. This is in, this is out. Suppose this is 1, this is 2. Now, if we consider this nozzle, first of all we have to consider the steady flow energy equation for a particular control volume for this particular device. That is, we can remember the steady flow energy equation. What? That is H1 plus half of V1 square plus Z Z1 plus dq by dm is equal to H2 plus half of V2 square plus Z Z2 plus dwx divided by dm for unit mass. This equation can be written as H1 minus H2 plus half of V1 square minus half of V2 square plus Z Z1 minus Z2 plus dq by dm minus dwx by dm is equal to 0. Now, if the system is adiabatic, so this system is adiabatic, so this heat flow, that means isentropic flow, this dq by dm is 0. There is no shaft work, so this part becomes 0. Z1 is equal to Z2, this part becomes 0. If we consider initial velocity V1 is much less than V2, that means if we consider V1 is much less than V2, so we can neglect, not 0, we can neglect this part. So, finally, the equation becomes what? The equation becomes half of V2 square is equal to H1 minus H2. Now, if, and mind that we are considering the actual case, that means actual case means 1 to 2, clear. So, if V is in, V2 is in meter per second and H kilojoule per kg, then the equation can be written as half 1 by 2 into 1000 into V2 square is equal to H1 minus H2. They both unit are same. So, V2 is equal to what will be root of 2000 H1 minus H2, and that will be approximate 44.7 root of H1 minus H2. So, this is the V2 for actual case meter per second, and if that will the previous concept we can use, this is actual, this is ideal. So, actual, so this can be written as 44.7 root of k into H1 minus H2s. Is it clear? V2 is equal to that. So, this is also a important relation, or you can say this is also an important relation which will require further. Now, next one is what? Next one is the subsonic and supersonic nozzle. Subsonic and supersonic nozzle. You can say the methods to define whether the device is nozzle or diffuser, act as a device, act as a nozzle or diffuser. First of all, to understand or to start this part, we should know different terminology, that means sonic velocity, sonic velocity, sonic velocity. Basically, sonic velocity is nothing but velocity of sound, which can be defined as C is equal to root of what? dP divided by d rho at isentropic condition. Okay. And after that, Mach number. Mach number. Mach number is nothing but the ratio of actual velocity of the object divided by sonic velocity, actual velocity v divided by c, and that has been defined by capital M. When m is greater than 1, this is called supersonic velocity. When m is less than 1, this is called subsonic. When m is equal to 1, this is sonic velocity. Now, start this topic, subsonic and supersonic nozzle. That means, the method to define whether the device is nozzle or diffuser, as I have told before that the same device can be act as a nozzle or diffuser, that depends on the condition of the gases or steam or fluid. Now, from the isentropic flow through the nozzle, we have in previous equation what? H1 is equal to H2 plus half of V2 square. That was the final equation. So, in differentiate form, we can write dH is equal to minus V into dV, if we consider this is the equation 1. And from the property relation, we can write, from the property relation, we can write what? We can write TdS is equal to dH minus V dP. Is that clear? Though this is adiabatic process, so ds is equal to 0, so this becomes 0. So, equation becomes ds is equal to V dP. Suppose this is equation 2, or you can see this equation is ds is equal to dP by rho. This is equation also 2. Suppose this is equation also 2. Clear? Now, if you put this value of dH here, we can write from this equation 1 and 2, we can write what? dP by rho is equal to minus V dV, where V is equal to velocity. So, dP by dV is equal to minus rho V. So, that means dP by dV is less than 0. So, therefore, as a pressure decrease for flow through a nozzle, the velocity will increase. The pressure will decrease, velocity will increase. Now, from the continuity equation, mass flow rate is equal to what? Rho into A into V. By the logarithmic differentiation, we can write d rho by rho plus dA by A plus dV by V is equal to 0, because mass flow rate is constant. Now, dV dA by A is equal to what? dA by A is equal to minus dV by V minus del rho by rho. Now, if you put the dV value from this equation, dV value from this equation, dV value, then we can write what? dV value अगर ये equation से हम लोग बिठाए तो क्या मिलेगा? That will be is equal to minus of dP by V square into rho minus d rho by rho, Now, the dA by A is equal to what? Is equal to, if you consider dP by V square rho, dP by V square rho, then the equation becomes 1 minus d rho by rho will eliminate it by what? That will be into V square into dP. So, this equation dP by V square rho 1 minus V by root of dP by d rho A whole square we can write, sorry, this is third bracket. So, this one is what? This one is C. So, V by C is nothing but Mach number. So, Mach number is equal to what? V by C. So, we can write this equation dA by A is equal to dP by V square rho, third bracket start 1 minus m square. If we put this value of P, then dA by A is equal to what will be? अगर P का वैल्यू यहाँ पर बैठा दिया जाए, so the equation becomes what? The equation becomes what? dV by V m square minus 1. Now, from this relation, what can we say? What can we say? When suppose this is conversion passage, in, out, this is suppose divergent passage. Okay, suppose this is divergent passage. Suppose in, out or exit. Suppose when the Mach number m is less than 1, what will be for that case? मतलब conversion passage. When m is less than 1, that means this becomes what? Negative. So, this third bracket becomes negative. That means A is going to decreasing, velocity is going to increasing and pressure is going to decreasing. So, conversion passage will act as a nozzle. When we consider this, matlab divergent passage, A is going to increasing, velocity is going to what? Decreasing and pressure is going to increasing. So, divergent passage act as a diffuser. When m is greater than 1, for same consider, when A is going to decreasing, velocity when m is greater than 1, that will be positive. So, m is going to decreasing, velocity also going to decreasing, pressure will going to increasing. So, that means convergent passes act as a diffuser, and when a is going to increasing, for that case velocity will going to a is going to increasing, velocity going to increasing, and pressure is going to decreasing. So, divergent passes act as a nozzle, and when m is equal to 1, that means this becomes 0. So, there will be no effect of cross section area, no effect of cross section area. That means there is no change of velocity with respect to change of flow area. In next lecture, we will discuss another part of this same topic. Thank you.